In 40 seconds, meet the three-electrode cell, working, reference, and counter, running in an electrolyte that lets ions move and reactions happen. The electrolyte is a solvent plus salt. Its job is to carry ions, not electrons, between electrodes. Think aqueous salts like KCl in water, or non-aqueous salts like LiPF6 in carbonate solvents. Conductivity is key. The working electrode is your reaction stage, often platinum, gold, or glassy carbon, sometimes polished metal films. Surface matters. Clean, smooth, and well-defined sites speed electron transfer and reveal true kinetics. You control potential and watch current at the working electrode. The current reflects the redox rate at its surface. The reference electrode provides a stable potential. Common choices are Ag, AgCl, or saturated calomel. It draws essentially no current. A salt bridge junction contacts the electrolyte so its potential stays rock steady. The counter electrode completes the circuit and balances current, often a platinum wire, driven by the potentiostat. Put it together. Control potential versus the reference, measure current at the working, and let the electrolyte carry ions. Now you're ready to run real electrochemistry.